element D will also see here our J. And if you look at the normal stress, which is equal to mz over izz multiplied by y, right? Element A and C will be equal to 0. Element B will be mz over izz multiplied by y. Element D, or element A, will be minus, B will be element D will be positive. Okay, multiplied by y. It does not matter, like what I told you all earlier, because Tresca criteria states that the shear yield in tension is equal to shear yield at compression. Either you analyze point A or point B, I don't think it doesn't matter at all. Okay. So there are the two formulas, so we know what formulas to use. We have to use this formula to find the normal stress. We also have to use this formula, one to find the normal stress, one to find the shearing stress. So we know that J is equal to 2I, right? Because it's a shaft, I is equal to, I think it's equal to, let me check, pi over 4, yep. Multiplied by R naught power 4 minus by radius internal power 4. Okay, so we have to get back to radius. So this will be equal to pi over 4. So we know that the shaft is what? Diameter is 30. So this is 0.015. And then the internal is 20, 0.01 power 4. So this will be equal to 0.015, 0.015 power 4 minus 0.01 power 4 times by shift pi divided by 4 is equal to 31. I get 31. Did I press my calculator? 0.015 power 4 minus 0.01 power 4 times by shift pi divided by 4. I get 31. Okay. Yeah, 31.907. Let me 31.907 times 10 to the power minus 9 meter 4. And then J, which is equal to 2I. So this is twice multiplied by 31.907 times 10 to the power minus 9. Okay, so 31 times by 2 is equal to 63.814 times 10 to the power minus 9. Okay, meter 4. I think the solution manual is quite smart. They use the pi, okay, and I think that's a good idea. But anyway, so either we choose element B or element D, okay, our answer will not be any different, okay. So the normal stress, right? So the normal stress was, so before we go any further, let's select, let's pick one, okay? Let's select element B. So if I were to select element B, which is the one at the top, okay, element B is here. So how does this look like? So element B look like this. And based on the shear, the torque is going in this direction. Okay, and we have normal stress down here. And if I have to put on our transformation, X, Y, and Z. So this is our stress X, okay? This is our shear XZ, and this is our shear ZX. Okay, so these are X and Y. So stress X for element B. So M, our moment is equal to what? We found out that our moment is equal to 90, right? So we know it's going to on compression minus 90 over I 31.907 times 10 to the power minus 9. And then the radius, okay, is 0.015. Okay, 0.01. So 90 times by 0.015 divided by 31.907 power minus 9 is 42.31 negative 42.31 times 10 to the power 6 Pascal. Okay. And then the shear XY or the shear XZ at point B, the torque is equal to what? The torque is equal to 12, not 12.5. The torque is equal to 360. Radius is 0.015 divided by J, which is equal to 63.814. Right. So 360 times by 0.015 divided by 63.814 power minus 9 is equal to 84.621 times 10 to the power 6 Pascal. Okay. So now we have to construct. Okay, I'm going to construct 3D mold circle now. Yeah, I'm going to construct 3D mold circle. So constructing 3D mold circle, I'm thinking which is the best to use. Okay. So I'm going to have my Z in this direction. Yeah. Then I'm going to have my X. And then I'm going to have my Y. Yeah, I'm going to flip this around. Okay. So XZ and then my Y. Okay. Then I know that this is my stress X, right? And because the way I flip it, right, this is my shear. So this is my shear. Intersecting plane is X, going the Z direction. Yep, and shear ZX. Okay. So now I'm going to sketch just a sketch. Okay. Now from here we have to sketch 3D mold circle. Okay. To find out is stress mean or stress max equal to 0. Right. This is the important part. Okay. We have to find out. Okay. And yeah, the quick answer is no, but I want you to in your exam you have to sketch this. Okay. So from here, right? you don't see the solution manual doing this because they take it for granted. Okay, we are learning. We cannot take it for granted. Okay, so you know what? I'm going to take this and I'm going to do on the next page. Right. If you were to see the solution procedure for this, it's exactly the same like what we did on Friday. Okay, the protocol is exactly the same. So from here, we have to construct 3D mole circle. This is normal stress. And then we have our shearing stress. Okay. Element rotate clockwise, element rotate anti-clockwise. And we know that if we were to label the element X, Z, Y, we know that Y is over here. And we are also aware that this is our stress Z line. Okay. And then by knowing that that's our stress Z line, this will be our stress X line. Okay. And then from here, again, this is just a sketch. This is our shear line. And this is our shear line. Right. And X, the element is going in the clockwise direction. And this is our Z. Okay. So now we sketch our 3D mole circle. And then from here, we can draw one circle. So this is one of the circle. So this corresponds to our XZ plane. And the XZ plane is our in plane. Right. And then there are the two circles. One is over here. And this is our YZ plane. And the last one this belongs to our XZ plane. No, XY plane. So we know that this is over here. This is our stress mean. Right. Over here, this is our stress max. Okay. So we know this now, right? So we also know that from here, right? From here, we know that from 3D mole circle, okay, stress mean is not equal to 0. So from here, we have to formulate or know that stress max is equal, shear max is equal to stress max minus by stress mean divided by 2. Okay, so we know that. So why I